If you keep retraining models because you can't reliably reload them, you're wasting time and risking mismatched artifacts. I'll show the clean Joblib Pickle workflow and how to verify the loaded model is identical. You have models that work on your machine but fail in production. You lose hours because you cannot trust a saved file. By the end, you will save, reload, compress, and version a simple model and know how to check that the reload is correct. We work concept first, then short Python examples you can reuse in projects. I'm Professor Pi, teaching AI foundations with Python from basics to advanced. Saving and loading models is a small task with big consequences. In practice, it solves deployment, reproducibility, and iteration speed problems. People reach for Pickle or Joblib because they are simple and fast for Python objects. The downside is compatibility and safety. Pickle produces bytes that are sensitive to Python and library versions. Joblib is often preferred when large numeric arrays are involved because it handles those arrays more efficiently. If you need cross-language deployment, other formats matter, but for many Python pipelines, these two are the pragmatic choice. Think of serialization as packing your trained object into a portable box. Pickle turns Python objects into a byte stream. Joblib wraps similar serialization, but optimizes storage for numeric arrays and offers built-in compression. A tiny example is a mean predictor that always returns the training average. That keeps the example focused and lets us test save, load, and equality without large data. Strengths are speed and convenience. Weaknesses are security and version coupling. We will build a tiny mean predictor, save it with Pickle and Joblib, test compression effects, and bundle a versioned artifact that we reload and verify. First, we fit a tiny constant predictor. This snippet fits a tiny mean model and makes constant predictions. It shows training by computing a single number, the mean of the training target, and storing that as the model parameter. The example keeps everything minimal, so you can focus on serialization behavior. After fitting, the model answers every input with the same predicted value. That makes comparisons trivial. It also surfaces floating point details, so when you later compare saved and loaded outputs, you will check exact equality or a small numeric tolerance depending on your needs. Next, we serialize to bytes and restore with Pickle. This example serializes the model with Pickle and restores it from bytes. It demonstrates how Pickle converts the model object into a contiguous byte stream in memory, and then how that byte stream can be turned back into a live Python object. The example highlights that Pickle works with in-memory bytes as well as files, which is handy for network transfer testing. Be aware that Pickle is not safe to load from untrusted sources, and different Pickle protocol levels can change size and speed. Changing the protocol number will usually change saved size and sometimes load performance. Now we load with Joblib and verify equality. This code loads the model with Joblib and verifies object equality. Joblib handles numeric arrays efficiently and may store large arrays in separate files or use memory mapping. The snippet shows saving with Joblib and reloading into a fresh object, then comparing predictions and core attributes to confirm the model behaves the same. Exact object identity is not expected because the reloaded object is a new instance, so the verification compares outputs and parameter values. If you see tiny numeric differences, you may accept them with a small tolerance, or use deterministic training to avoid them. Then we toggle compression to see file size trade-offs. This snippet toggles Joblib compression to change serialized model size. It saves the same model with different compression settings and compares resulting file sizes and load times. Higher compression reduces disk footprint, but increases CPU work on save and load. Low or no compression is faster for local iteration. When you plan to transfer models over the network, pick higher compression to save bandwidth. The snippet also highlights how compression affects save duration. and memory behavior when loading large arrays. Finally, we package a versioned model and reload from bytes. This example bundles a versioned model, saves to bytes, and reloads it. It shows attaching metadata, such as a model version string and a small manifest with library hints, then serializing the bundle into bytes for storage or transfer. On reload, the snippet checks the version tag and warns if there is a mismatch. This practice increases the bytes stored, but gives reproducibility and safety when moving artifacts across environments. Including version metadata makes it easier to trace what code trained a model and to handle migrations later. After the hands-on snippets, do a few practical checks every time you load a model. First, run the reloaded model on a small test set and compare outputs to the original model using exact equality or a numeric tolerance. Second, compare core parameters or the single mean value in our example to ensure no corruption. Third, include metadata with package versions and a training timestamp so you can detect incompatibility. Also add unit tests that save, load, and assert that predictions are stable. Finally, never unpickle data from unknown sources. Prefer Joblib for heavy numeric artifacts and keep a reproducibility checklist. Recap: it is serialization of Python models using Pickle or Joblib. Use it when you need fast save and restore in Python workflows, especially for numeric arrays where Joblib helps. Caveat: untrusted bytes and cross-version incompatibility require careful handling and metadata. Next step, put the same save and load steps into a continuous integration test that measures save size, load time, and prediction equality on a small validation set. If AI Foundations in Python help you, subscribe and watch the AI Foundations videos.